So let's start with this wine quality demo. So I will just first introduce myself. I'm Badr Ouali. I'm a data scientist working for Vertica for almost now 2 years. I really enjoy helping people and my customers to understand their data and all the possibilities that they have. I love mathematics, football, and many other things. So right now, I will present the wine quality demo. This demo will show you all the SQL behind the scene, all the Vertica SQL behind the scene, and we will deal with an interesting use case to understand what is machine learning and how can we use it. So we will touch many topics right now. So we will use some classification first, because we will have a rate of all the wines. And so we can analyze and just try to say if a wine is good or not. Then we will use a regression model in order to have a really relevant score for each wine. We will use also cross-validation, and we will deal with many machine learning models. So during this presentation, we will follow the entire machine learning process. So we will try to understand the business, and I insist in this point because it's one of the most important points, because if we don't understand the business, we cannot do a good data preparation, so we cannot build a really efficient model. You must know that in the data science, in a data science project, data preparation is almost 90% of the study, even more in some cases, because building a model is just 1 or 2 lines, and when the data is well prepared, it's done. The model will be accurate. So first, let's do some business understanding and try to find the best strategy to predict if a wine is good or not. For this study, I'm using right now a very famous data set, which is called the wine quality data set. It was done by a PhD student who wanted to do a regression model around wine, and he extracted the chemicals around 5,000 of wines. So if you want to see this data set, you can go directly on Kaggle. But in the future, I think that I will have my own data, because now I'm extracting with my machine the wine chemicals. So what is a good wine at the end? Because we will hear a lot of times these 2 sentences. I love this wine and this wine is good. When you love something, it's more subjective. So it's not really what a good wine is. Because for example, for myself, I really like coffee without sugar. It doesn't mean that the coffee is necessarily good. A lot of people will say, oh, it's a really bad coffee because there is no sugar. But a coffee is not defined. The quality of a coffee cannot be defined with the quantity of sugars. And you can be also impartial and say this wine is good because you know how to analyze wine, you have an experience with wine, so you know the components that makes a wine good. Most of the time, for a good wine, everyone will like it. So some people will not say that, oh my God, I love it, but there is no divided opinions. Whereas with a bad wine, the opinions are really divided. So at the end, what is a good wine? We need to study what makes a wine good. So there is three different factors. First, the wine has no default. So you cannot see a grape inside, some grapes inside your glass, or you cannot smell a really bad taste. In this case, the wine has default, so immediately it will not be a good wine. The wine must have a good equilibrium. We will see it. It's a really important point because it's related to the chemicals that we will extract. And at the end, the wine must have a fine length in the mouth, which means that when you drink it or just spit it after testing, the taste of the wine stay in the mouth during a certain amount of time. If it is fast, it's not a good wine at all because it's really related to the quality of the grapes. So as I already said, when the wine has no default, there is 3 factors: no visual default, no olfactive default, and no gustatory default. But this part is directly it's really easy to see, because with this part, you will directly, for example, when you will smell the wine, you will directly feel if there is a vinegar smell, or you will see there is directly a default of the wine. So it's a really easy part. But the most interesting one is this one. The wine has a good equilibrium. What is a good equilibrium? We have three main variables, which are the tannin, the acidity, and the smoothness. And we will define a wine according to these three components. The wine can be liquorous, syrupy, heady, fatty, depending on the composition. And a good wine must have a real good equilibrium between these three elements. A wine that has too much acidity will not be good, or too much tannin will not be good. We really need this equilibrium. And at the end, the wine has a fine length in the mouth, which means that you have long tasting aroma, you have a perception of a really good flavor and a good equilibrium. For more information, you can read the article of Yann Rousselin, who, this article is in French, so you can perhaps use Google Translate if you want to read it. It's a really good article by a wine expert who helped you to define what is a good wine. So why I'm doing this? Because I need to understand the business. I need to know which component I must extract in order to build an accurate algorithm. Just imagine that I don't know this information and I go randomly to solve this use case. Most of the time, it will fail. That's why I insist on business understanding and then data preparation. And then what if we can use the Euclidean space, have all the chemicals of the wine, all the variables that will influence if the wine is good or not, and then separate. That's the link with big data. Just imagine that we can rate billions and billions of wine. We could create a really accurate algorithm which can detect for any wine if it is good or not. If we don't have this kind of data, we need to deal with only one brand of wine. Let me explain myself. First, what is mandatory in the study? We must compare two wines of the same type. So we cannot compare a red wine to a white wine. It doesn't give any sense. The white wine will be more sweet than a red wine in general. It doesn't mean that a white wine is better than a red wine. We must compare comparable elements. And except if we have enough data, we can only compare wines of the same winery, because some machine algorithm will work linearly, which means that they will make automatically some assumption. For example, a linear regression will say, according to its coefficient, if the more alcohol degrees you have in the wine, the better it is, which is not necessarily the case for all the wine. That's why I insist into having enough data to use big data and to use the correct algorithms at the moment. And one of the most important points is to have an impartial wine expert. And it's really important and the hardest part to do, because a lot of people will rate with their own point of view, which is really subjective. And we need someone who can feel, even if he doesn't like when there is a lot of tannin, when he feels the equilibrium, he must rate well the wine. And it's really hard to feel this part. How should we proceed? So we have the winery. The winery will produce some wine. We will use a wine analyzer to extract all the chemicals. And then we can give this glass of wine to a wine expert, and this wine expert must score the wine between 1 and 10, or any rate you want, between 1 and 5 if you want, in order to have this value that the machine learning algorithm will use to build a model. And then, thanks to the rate between 1 and 10 and the chemicals, we can build this machine learning algorithm, this machine learning model to rate a specific brand of wine. So now that we understand Let's do some data exploration and try to understand the data in order to find the best strategy to rate a wine. Because now that I understand the business, I know the components that will influence the quality of the wine. So let's do it. So we have in this data set all these variables, the fixed acidity, the volatile acidity, and many other variables. But what we can notice is that we don't have the tannin. And it's really important. So the guy who shared this data set missed something, because he wasn't a wine expert. He didn't know that we need to extract the tannin and see if we have an equilibrium between the wine. He just did it not randomly. He just thought by himself, let's extract some components, and then perhaps we will find what is a good wine according to the chemicals. But he was wrong, because he didn't extract one of the most important variables. But now we must deal with it, because the business understanding was not working well. And that's what I advise to all my customers. Just try to understand the business, have a clear idea in mind in order to do a real business understanding, and then we can speak about machine learning and all the data science parts. So let's do some data exploration, as I said, and what we can see that we have all these different components, but we can use some functions that we have directly in Vertica, some function for data exploration. We have many functions for this, and we have this function called summarize new column, which is totally similar to describe in pandas, in Python pandas, or summarize in R. Having all the statistical information about all the components is really important to build a strategy. As you can see in our data set, some wines are really weak. We have less than 10 degrees of alcohols for some wine. Some are reaching 8 degrees. You know, it's really weak for a wine, whereas some has the typical amount of alcohol in wine, which is around 12. We have some wines are really salty too. We can see that the number of chlorides can reach 0.009 for some wine and can reach 0.6, which means really salty wine. The density can be really low for some wine, which means that the fermentation is over, but for some others, the fermentation is not over, so we cannot use them for the prediction. So we need to understand the data, and we have other components. So having this kind of functions can really help for the data exploration, and you can do it with one line of SQL. So when we will use some summarize cat column, so it's another functionalities for categorical columns, we can see that we have a lot of white wine and a lot like 1/4 of red wine, which means that we need to split this data set into two data sets, one for white, one for red. I just want to add something. Is for white wine, the strategy must be different because there is no tannin in the white wine. So we cannot deal with tannin, so we can use the smoothness and the acidity. So the study is correct for this one. But for red wine, we are missing something, and we are mostly studying red wine in this study. And we can see the quality. We can see that most of the wine are rated between 5 and 7, which is not bad because it's totally normal. Just imagine that you put a wine into production in the supermarket and it's a really bad wine. So I don't know where the marketing could be in this way. The wine must be at least 5. 4 and 3 as rate are mistakes, are wine where the fermentation is not over, or the bottle was not closed in the correct way. That's why what I'm saying is like 5 is a normal rate for a wine. But we have a small amount of wine that are excellent, having a rate of 8 and 9. We can use Vertica ML Python to plot a correlation matrix. This API I created can generate the SQL behind the scene to help you for visualization and the machine learning process. And thanks to the correlation matrix, we can notice two things that are really correlated to the quality of the wine. We can see that the wine quality is highly correlated to the alcohol and volatile acidity. It's really important to look at the correlation matrix, especially for the row related to the response column, because we can understand when a specific wine is good or not. And looking at this matrix, we can see that the higher the alcohol degree is, the better the vinho de verde, this specific wine is. Whereas the lower the volatile acidity is, the better this wine brand is. But when we understand the business, when we understand that we need equilibrium between the variables, we can create some kind of ratio, like for example, the alcohol over the pH, which can be another variable. And what we can notice, it's highly correlated with the response column. And how could I create this kind of variables? Because I understand the business. I'm not working in a winery. I'm just a data scientist. So a data scientist must understand wisely the business before creating features. Just imagine you're using a tool to generate automatically features. You cannot think about this kind of features, ratio between variables, or using a specific mathematical functions applied directly on another variable to create a features. And now we created the really interesting features that is has a correlation of 0.5, which is really high. And then we can do some plots using, again, the Vertica ML Python to understand what is a good or bad wine. Just to keep you informed, when you have a huge amount of features, it's really hard to use visualization. So that's why you must use some other technique like PCA to reduce the number of variables. But right now, I'm just using the typical variables that I had at the beginning in order to plot this scatter plot and this X-bin plot. And we can see that really bad wine have a small alcohol degree composition. And we can notice a really bad wine that has a lot of chlorides. The one that is really salty is not good at all. But now let's prepare the data. I'm preparing new variables. We can create interesting ratio, but as I don't have the tannin, I cannot create the ratio between the tannin and the acidity, or the tannin and the smoothness, the tannin and the alcohol, the tannin and the residual sugars. But let's deal with it, because the next time when I will extract components myself, I will have a perfect data set because we understand the business. Then we can do some model creation, and in Vertica it's quite easy. So I'm using a split column I created to split the data into a train and a test. But what we can do is also using a table sample statement at the end of the SQL query to generate two different samples, one for testing and one for the training. Then I can use a simple line of SQL to build a logistic regression model using only the features I'm interested in. There is this using parameters clause that can be used to indicate the parameters you want to use to build your algorithms. And when it's built, you can use this get model attribute functions in order to get the coefficient, the standard deviation error, the z-value, the p-value, etc. All the information needed to understand which are the important features. And as you already perhaps know, the p-value can indicate if we need to reject some variables or not when they have a really high p-value. So we can reject a lot of different features for our next training. And then we can evaluate our models. We defined here a good wine as a wine which is rated over 7. I forgot to tell you the information. And in this case, I'm dealing with classification, and I have a very good model with a good AUC and a good accuracy. But now what I will build just right after, so I'm still analyzing the model, because in Vertica you have the lift table to see the gain for all the data set, or you have the AUC RAC curve that you can generate with SQL, and then you can use an ODBC or JDBC connection to your usual tool to plot it easily, because you already have it in Vertica. And you can also see the importance of all the variables. We can see that the ratio we created is the second most interesting variables, and the most interesting variable is the alcohol quantity, which is totally normal, because just imagine when you have a really low alcohol degree for a red wine, means that your fermentation is not over, so your wine cannot be good. And we can understand all the important variables, reject the other one to build another model. But now let's build a regression model, as we have rates between 0 and 10. And in order to build it, we can use a cross-validation function that we have in Vertica. Yes, we have a cross-validation in Vertica, and I can indicate the number of faults using as metric, for example, the accuracy and AUC, and I can see that even the SVM classifier can be good to separate the data. But for the regression, I'm using a linear regression, and I can see a really low MSE, which is around 0.443. I can use the square root of this number in order to have, let's say, a bound, a range where I'm sure of my prediction. When, for example, the MSE, the square root of the MSE is equal to 0.5, I have an imprecision of my rate of 0.5. So if I predict 6, the rate will be mostly between 5.5 and 6.5. And then I can deploy the model. So for now, I was using refractometer, pH meter, to extract the component of my Vinho de Verde wine. And then I can use the linear regression. I can build a model and then just use it directly to rate the wines that I have lively. So next time, I will have a machine to extract the components, and we can also do some data ingestion directly to the Vertica database. And the question is, what if? What if we could have a lot of wine experts extracting all the chemicals of the wine, tasting it, rating it, doing the in-database machine learning to rate any wine? We could rate any wine. For example, you can go to a restaurant, and then a guy can tell you your bottle of wine will cost between $5 and $50. We can use the algorithm to have the exact amount. And it can give some kind of, how can I say, suspense, and you can love your dinner with a good bottle of wine. So thank you very much. I hope you enjoyed this presentation, and don't forget to try now the community edition. It's free up to 1 terabyte. You have and free nodes, and you can easily test this demonstration where the data is available on Kaggle. And if you want, you can contact me and I can send you the notebooks. So thank you very much.